Hi guys, today's lesson is going to be on trapezoids. We're going to take a look at all the properties that trapezoids have. Okay, so let's talk about the definition of a trapezoid. A trapezoid is a quadrilateral, again a four-sided figure with exactly one pair of parallel sides. So they only have one pair of parallels, making them different from all the parallelogram shapes. So what we talk about the parallels here, if you notice in this picture, the parallels, of course, are marked with the little arrows on them, but those two parallel sides are the bases. Okay, they're called the bases. And then the two other sides, okay, each of the non-parallels, the ones that are not parallel, are called the legs. Okay, so the parallel sides are the bases, and the non-parallel sides are called the legs. Now, at each base, there is a pair of angles called base angles. So there's a pair of base angles here, okay, because that's one base, and there's going to be a pair of base angles over here as well. Base angles are two consecutive angles whose common side is a base. These are consecutive, one right after the next, and their common side is a base. So once again, we have another pair over here. Pair here and a pair here, okay? In isosceles trapezoids, and we're going to talk about that in a minute, but in isosceles trapezoids, those two legs are going to be equal, and the base angles are going to be congruent. Now, I know you have heard this term before. When you have an isosceles triangle, right, the legs are the two equal sides, and the two angles that are equal are called base angles. So we have heard this before, right? It's very similar in the concept of your triangle, the isosceles triangle, and of course the isosceles trapezoid here. Not all trapezoids, those guys, are isosceles. You can have a trapezoid look like this, right? You have a pair of parallel sides, but the other two sides there, they're not going to be equal to each other. Okay, so trapezoids typically look, like this, like you're used to looking at them, but they can look different. They can even have the parallel sides going this way, right? And have this and then maybe a longer side over here. And your parallel sides could be the bases going up and down as opposed to, horizontally across. They could go vertical. So don't think that all trapezoids are going to look like this, okay? Specifically, when we're looking at this type, it's considered the isosceles trapezoid. All right, so let's look at the isosceles trapezoid. They have to have two congruent sides, of course, for an isosceles trapezoid. You have to have a pair. It says right here, a trapezoid has isosceles if and only if its legs are congruent, okay? So if the two legs are equal, then it's considered isosceles. It also has base angles congruent. So those base angles I was talking about up here, when your two sides are equal, these two angles are going to be equal to each other and these two. So in this picture right here, what you're seeing is this is a pair of base angles. These would be my parallel sides here, right? And then this up at the top here would also be a pair of base angles. And in isosceles trapezoids, those base angles are congruent. So again, those are equal and those are equal. And it says here, a trapezoid has one pair of congruent base angles. If it has one pair, then it's isosceles. So what's going to happen is if it has one pair, the other pair will automatically be equal there. Now, there is something else the isosceles trapezoid has, and it's right here. It talks about the diagonals. The diagonals of an isosceles trapezoid are congruent. So we saw congruent diagonals before. Rectangles have congruent diagonals and squares have congruent diagonals. The trapezoid also has congruent diagonals. So in other words, not the trapezoid, I'm sorry, the isosceles trapezoid. Only isosceles trapezoids have this. The length of this diagonal is equal to the length of that diagonal. Now, be careful. They do not bisect each other. They don't cut each other in half. So that little piece is not equal to that piece, and that piece there is not equal to that piece. So just be careful. They don't cut each other in half, but the entire lengths are equal to each other. All right, so the isosceles trapezoids have a few things. General trapezoids do not have a whole lot. Let's take a look at this for a second with all the properties. All right. First of all, in general, again, what you're seeing here is we had graphic organizer that looked like this, right? Where we had the parallelogram, quadrilaterals. We have one of the types of quadrilaterals or parallelograms. The parallelogram gives all of its properties to the rectangle and the rhombus, and then the rectangle and the rhombus give all their properties to the square. The trapezoid is a different type of quadrilateral. It's in its own family. So over here, we can see that the trapezoid has one pair of parallel sides, and of course they're the bases. And it has two pairs of same side interior angles that are supplementary. Let me go back to this picture. Actually, we'll go to the bottom picture down here so I can talk about that for just a second. These two angles that are right here, this one and this one, that's what I'm talking about by supplementary, right? These are my same side interior angles. And they add to 180, and likewise, these two also add to 180. And again, remember why. These are parallel, here and here. This side would be a transversal. Let's use a different color. This side would be a transversal here, causing that and that to be same side interiors. So there's one pair of same side interiors here, and there's one pair here. That's why you see that property there that says two pairs of same side interior angles are supplementary. In parallelograms, over here, we had all the consecutives were supplementary. So again, this one and this one added to 180, right? But this went all the way around the picture. This one and this one added to 180, right? That doesn't happen in the trapezoid. You only have two pairs instead of four pairs. There were four pairs of consecutive angles that are supplementary in the parallelogram. The trapezoid does not have that. It only has a pair here and a pair here. And when your trapezoid is isosceles, like this one here, right, it's got special properties as well. The two legs are going to be congruent, right? It has, let's see, where is it? One pair of congruent sides. That's the legs. The two legs are congruent. And it's not the bases that are equal. It's going to be the legs. It has two pairs of base angles congruent. We talked about the fact that it's going to be this angle is a pair of base angles. Those two are equal. And this is another pair of base angles. They're the angles along the base. They are equal. So the two pairs of base angles are congruent. This is an interesting one. The opposite angles are supplementary, which means, you know how in parallelograms we had opposite angles that were equal, like those two are equal, these two are equal? When you have an isosceles trapezoid, your opposite angles there are actually supplementary. These two will add to 180, these two will add to 180. And let's think about the math here. If this angle was 60 and this angle was 120, right? And the base angles are congruent, so that has to be 120. And these base angles here have to also be congruent, so that's 60. These two would add to 180, because remember we have a pair of consecutive angles here that are supplementary and a pair over here. So what you have in the end, if you look at it, your opposite ones will end up being supplementary there. And of course, the last thing we saw in this is that our diagonals are congruent to each other. So that length there is going to be equal to this length over here. So the diagonals are congruent. That's the last thing the isosceles trapezoid has. Okay, let's go back to some problems and try some problems. So if we look at this first one here, you've got these two sides here equal. So we know it's an isosceles trapezoid, and it's telling us the base angles are congruent because that's our property that we have for isosceles trapezoids. So we know that if that angle is 124, so is that one. Okay. Also, we have another pair of base angles here. These two are going to be equal as well. It says, find angle J. Well, remember, we have two pairs of consecutive angles that are supplementary. So these two angles right here have to add to 180. So I can take 180 minus 124 for that, and I'm going to get 56. So what happens is angle J is 56 and also angle M. And it asks for the measure of angle J. So J is 56 degrees. Okay, let's look at the next one over here. In this problem, we're looking at the diagonals. That's what we're focusing on. This diagonal length here is going to be equal to this diagonal length right here. These are equal to each other. All right, so what do we have? Let's see. It tells us that F to H, all of this diagonal here is 9. So if all of that is 9, that means all of this is 9, right? So if your FH is equal to 9, also your EG is equal to 9. So if this whole thing is 9, and they're asking us to find A to G, that's what we have to find there, A to G, we have to take the entire length of 9, right, EG, and subtract EA from it, and that will leave us with AG. That will leave us with AG. So the whole thing is 9, take away the 6.2, and I'm left with 2.8. So the length of AG there works out to be 2.8. Okay? All right, let's do the next problem. Find the value so that each trapezoid is isosceles. So again, we know that if it's an isosceles trapezoid, your base angles will be equal to each other. So this angle right here is going to equal that angle right there. So let's set that up. 5x squared plus 32 is equal to 7x squared. All right, let's combine like terms. We have a 5x squared and a 7x squared. So I'm going to subtract 5x squared on both sides. I get 2x squared over here is equal to 32. Let's divide by 2 on both sides, and we get x squared is equal to 16. And then to get rid of the x squared, remember we have to take the square root of both sides. So we're going to take the square root of both sides, and x works out to be 4. All right, so that's our value of x. X is 4. And of course, we could plug it back in and check to make sure it works. 4 squared is 16. 16 times, what is that, 5 there? Okay, we can get out our calculator and do the math. All right, so let's pull that out and just double check this to make sure it works. So we've got 4 squared is 16. 16 times 5, you can see this here, equals 80. Plus 32 just comes out to be 112, so that angle was 112. And then we have 7x squared, so x squared is 16. 16 times 7 is, of course, also 112. So we can see there that that works. All right, look at the next one. The next one, it's telling us that all of AC is 2z plus 9, and all of BZ is 4z minus 3. Now remember, the diagonals are congruent. So 2z plus 9 is equal to 4z minus 3. All right, combine like terms. We subtract, we get 2z left over here. Add 3 to the other side, we get 12. Divide by 2, and our z value is equal to 6. And again, if we plugged it in, we would find out that the values were equal to each other. So z is equal to 6 on that one. Okay? All right, let's go on to the next page. This concept is going to be sort of similar for you, or familiar to you. If you recall the word midsegment, we had that back when we talked about triangles. This is the concept of a midsegment here of a triangle. The segment that connects the midpoints on both sides of the triangle there, it's also parallel to the base. So it connects midpoints on both sides and it's parallel to the base. But what we remember is the length of that midsegment is equal to half of the base, okay? Our midsegment of a triangle equals half the base. So if this is x, this is 2x. Half of 2x would be x. Double the x and you get 2x. So if we recall that, this concept's going to be very similar, except trapezoids now have two bases. So the midsegment of a trapezoid is a segment whose endpoints are the midpoints of the leg. So again, it's connecting midpoints on both sides, and it is also parallel. All of these lengths would be parallel to each other. Just like up in this one, they would be parallel as well. Now, trapezoids have two bases, triangles have one. So we can't just take half the base because there are two bases. So this time what we're going to do is we're going to add the two bases and then cut it in half. This length here is half of the sum of the two bases. So we're going to add the two bases together and then cut it in half. All right, I like to think of this formula as take the two bases, add them together, divide by 2. These are the same thing. Whether I multiply by a half or I divide by 2, it's the exact same thing. But I like to use this. I just feel like it's a little easier to set up in the formula. Okay, so if you notice, I've set it up for each one of these. So let's find the length of KL. We're going to call that our x. So the midsegment is equal to 16 plus 26 divided by 2 there. Okay, that is going to give us our midsegment. So we get x equal to 42 divided by 2, and x works out to be 21. So KL is equal to 21 there. Let's do the next one. This time we don't have PQ. I'm going to call that x. So let's set it up. 7.5 is the midsegment, is equal to the base plus the other base divided by 2. Okay, so how do you solve this problem? Well, what I would do first is get rid of that 2 in the denominator, right? I would multiply both sides by 2 to get rid of the 2 on that side. So 7.5 times 2 is going to be 15, is equal to x plus 5.5. Now I'm going to subtract the 5.5, and I end up with 9.5 equaling that x. So the length of PQ there is equal to 9.5. All right, let's look at the next one. Okay, same idea, right? We don't know EF. That's the midsegment. So this time we're going to take 4.3 plus 14 divided by 2. So when I do 4.3 plus 14 divided by 2, my value works out to be 9.15. So EF there is 9.15. Let's look at the next one. This time we don't have WX. So our WX is one of our bases. So we have to plug that in over here. So 22.9 is equal to x plus 35 divided by 2. Again, I've got to get rid of that 2 on the bottom. So I'm going to multiply by 2 on both sides there. That's going to cancel out. 22.9 times 2 is 45.8 equals to x plus 35. Subtract 35 on both sides, and I end up with 10.8 for that x value. So WX is equal to 10.8. All right, in the next problem here, we have to find an x value. All right, same formula, okay? Don't get yourselves confused. Mid-segment there is 10. So 10 is equal to 2x minus 1 plus 4x plus 3 divided by 2. All right, let's combine like terms. So 10 is equal to, I've got 4 and 2, that's 6 x's, and negative 1 plus 3, there is going to be plus 2. Okay, and that's all divided by 2 there. All right, let's multiply both sides by 2 to get rid of that 2 on the denominator. Okay, so that's going to make us have 20 on this side is equal to 6x plus 2. Subtract 2 on both sides. I'm left with 18 is equal to 6x. And finally, x is equal to 3. Okay, so there's your x value. X works out to be 3. All right, on this last problem here, we have a combination of concepts. First of all, they're telling us that all these little tiny pieces are equal here, and all of these are equal on this side. That's what all that information is telling us there. Those are all equal, those are all equal. And g to h is equal to 36. How am I going to solve for the rest of this? Well, if you remember, back at my problem up here, the very top, we had this picture. We have a triangle where the mid-segment there is half the base. We're going to use that concept for this question down here. You have a triangle right in here, right? Remember something, they're connecting midpoints, so they have to all be parallel. This, let's call that one x, and let's call this one 2x. And now, if I do that, I have all the information I need to use my mid-segment formula. So let's set it up. Mid-segment is equal to base plus base divided by 2. All right, so let's plug everything in. So I have 2x is my mid-segment equals base plus base divided by 2. First thing I want to do is get rid of that 2 on both sides in that denominator, or multiply by 2 on both sides to get rid of the 2 in the denominator. So that gives me 4x on this side is equal to x plus 36. Subtract x on each side. So I'm left with 3x equals 36. So x works out to be 12. Okay, x works out to be 12, but we have to plug it back in. So let's find jk. jk is the x value, so we can put x right in there. We also have to find lm. lm is right here, and 2 times 12 will be 24. Okay, guys? If there's any part of this lesson you want to go back and rewatch, feel free. All right, good luck.